Proposal Report of CMP-2, Proposal Number 2-134 addresses NEC Section 210.12b and has been accepted. The current language states that arc fault circuit interrupters installed in accordance with 210.12 shall be of the listed type and shall be installed at the origination of the branch circuit. An AFCI installed at the origination of a branch circuit shall be permitted to provide protection for more than one branch circuit where the requirements of 210.20 are met. The proposed language revises this to state that arc fault circuit interrupters installed in accordance with 210.12 shall be of the listed type and shall be installed at the origination of the branch circuit or a listed AFCI combination type installed to provide protection of the branch circuit. An exception is added stating that an AFCI shall be permitted at other than the origination of the branch circuit under the following conditions. Firstly, the AFCI is installed within 1.8 meters, which is 6 feet, of the branch circuit overcurrent device. Secondly, the circuit conductors between the overcurrent device and the AFCI are in metal raceway or a cable with a metallic sheath. The explanation for this change is that the proposal revises the current language to allow listed AFCIs combination type to provide protection for the branch circuit. It also adds an exception to allow AFCIs to be installed other than the origination of a branch circuit under certain conditions. The substantiation for this proposal is that the current language in 210.12b requires AFCIs to be installed at the origination of the branch circuit. This can be impractical in some cases, such as when the branch circuit is long or when there are multiple branch circuits in a single raceway. The proposed revision would allow AFCIs to be installed at other than the origination of the branch circuit under certain conditions, such as when the AFCI is installed within 1.8 meters or 6 feet of the branch circuit overcurrent device and the circuit conductors between the overcurrent device and AFCI are in metal raceway or a cable with a metallic sheath. The proposed revision would also allow listed AFCIs combination type to provide protection for the branch circuit. This would allow AFCIs to be installed in combination with other devices, such as ground fault circuit interrupters or surge protectors, in a single device. This would save space and reduce the number of devices that need to be installed. In essence, the revision to 210.12b provides greater flexibility in the placement and type of arc fault circuit interrupters used for branch circuit protection. The allowance of combination type AFCIs acknowledges the advancements in AFCI technology. Combination type AFCIs are designed to detect a broader range of arc faults, including parallel and series arcs, providing more comprehensive protection against electrical fires. The introduction of an exception for AFCI installation location addresses practical challenges encountered in certain electrical installations. Requiring AFCIs to be installed exclusively at the origination of the branch circuit can be problematic in scenarios involving long circuit runs or multi-circuit raceways. The exception permits AFCI installation closer to the overcurrent device, provided specific safety measures are implemented. These measures include limiting the distance between the overcurrent device and the AFCI to 1.8 meters or 6 feet, and ensuring that the intervening conductors are protected within a metal raceway or cable with a metallic sheath. This approach minimizes the risk of arc faults occurring in the unprotected portion of the circuit. The use of metal raceways or metallic sheath cables provides a grounded conductive path, which helps to contain and quickly clear any arc faults that may develop. This enhances the overall safety and reliability of the electrical system. By allowing AFCIs to be installed in combination with other protective devices, such as ground fault circuit interrupters or surge protectors, the revised language promotes space savings and simplifies installation. This is particularly beneficial in applications where space is limited, such as in residential panels or commercial distribution boards. The combined functionality of these devices within a single unit streamlines wiring and reduces the potential for errors during installation. The acceptance of this proposal reflects a commitment to improving electrical safety while also addressing practical concerns and technological advancements in the field. The changes to 210.12b strike a balance between ensuring effective arc fault protection and providing flexibility for electrical installers. The revised language promotes the use of advanced AFCI technology and allows for more efficient and safer electrical installations. By understanding the details of this code change, electrical professionals can ensure compliance with the latest safety standards and provide enhanced protection against electrical fires. The importance of arc fault circuit interrupters in preventing electrical fires cannot be overstated. Arc faults, which are unintentional electrical discharges, can generate intense heat and ignite nearby combustible materials. AFCIs are designed to detect these arc faults and quickly interrupt the circuit, preventing a fire from starting. The NEC requirements for AFCI protection have been steadily expanding over the years, reflecting the growing recognition of the dangers posed by arc faults. The changes to 210.12b represent another step forward in enhancing electrical safety and reducing the risk of electrical fires. To fully understand the implications of this code change, it is essential to consult the latest edition of the National Electrical Code and any applicable local amendments. Electrical professionals should also stay informed about new AFCI technologies and best practices for installation and maintenance. Continuing education and training are crucial for ensuring compliance with the ever-evolving electrical codes and standards. By staying up to date with the latest information and advancements, electrical professionals can provide the highest level of safety and protection for their clients and the public. In summary, the acceptance of Proposal 2-134 and the resulting changes to NEC Section 210.12b have significant implications for arc fault protection. The allowance of combination type AFCIs and the introduction of an exception for installation location provide greater flexibility and efficiency in electrical installations. By understanding the details of this code change and staying informed about the latest AFCI technologies, electrical professionals can ensure compliance with the latest safety standards and provide enhanced protection against electrical fires. Remember to always consult the latest edition of the National Electrical Code and any applicable local amendments for specific requirements in your jurisdiction. The specific requirements of NEC Section 210.12b are designed to minimize the risk of electrical fires caused by arc faults. Arc faults can occur due to damaged wiring, loose connections, or insulation breakdown. These faults can generate significant heat, which can ignite surrounding materials and lead to a fire. AFCIs are designed to detect the unique characteristics of arc faults and quickly interrupt the circuit, preventing a fire from starting. The NEC requires AFCI protection in specific locations, such as bedrooms, living rooms, and dining rooms in dwelling units. The expansion of AFCI requirements over the years reflects the growing recognition of the importance of arc fault protection in preventing electrical fires. The changes to 210.12b further enhance the effectiveness of AFCI protection by allowing for more flexible installation options and the use of advanced AFCI technologies. The allowance of combination type AFCIs is particularly significant because these devices are designed to detect both parallel and series arc faults. Parallel arc faults occur between conductors, while series arc faults occur within a single conductor. Combination type AFCIs provide more comprehensive protection against both types of arc faults. The exception for AFCI installation location addresses practical challenges encountered in certain electrical installations. Requiring AFCIs to be installed exclusively at the origination of the branch circuit can be problematic in scenarios involving long circuit runs or multi-circuit raceways. The exception permits AFCI installation closer to the overcurrent device, provided specific safety measures are implemented. The requirement that the conductors between the overcurrent device and the AFCI be protected within a metal raceway or cable with a metallic sheath is crucial for minimizing the risk of arc faults occurring in the unprotected portion of the circuit. Metal raceways and metallic sheathed cables provide a grounded conductive path, which helps to contain and quickly clear any arc faults that may develop. This enhances the overall safety and reliability of the electrical system. In addition to the specific requirements of 210.12b, it is important to follow all applicable installation instructions and best practices when installing AFCIs. Proper wiring techniques, secure connections, and careful handling of the devices are essential for ensuring their effective operation. Regular testing of AFCIs is also recommended to verify their functionality. AFCIs should be tested periodically using the test button on the device. If an AFCI fails to trip when tested, it should be replaced immediately. By following these guidelines, electrical professionals can ensure that AFCIs provide the intended level of protection against electrical fires. The changes to NEC Section 210.12b represent a significant step forward in enhancing electrical safety. The allowance of combination type AFCIs and the introduction of an exception for installation location provide greater flexibility and efficiency in electrical installations. By understanding the details of this code change and staying informed about the latest AFCI technologies, electrical professionals can ensure compliance with the latest safety standards and provide enhanced protection against electrical fires. Furthermore, consider the practical implications of this revised code section. Firstly, for new construction, electrical contractors now have the option of using combination type AFCIs, which offer broader protection. Secondly, in existing buildings where retrofitting AFCIs at the panel might be difficult due to space constraints or wiring complexities, the exception allows for installing the AFCI closer to the point of use, within 1.8 meters, provided the wiring between the breaker and the AFCI is protected. Thirdly, installers need to be aware of the specific requirements for the wiring method between the overcurrent device and the AFCI. Using metal raceway, such as EMT or rigid conduit, or cables with a metallic sheath such as AC or MC cable, is crucial to meet the exception. Fourthly, this change might influence the design and layout of electrical circuits, encouraging shorter branch circuit runs and strategic placement of overcurrent devices to facilitate AFCI installation. Fifthly, manufacturers may develop new products that integrate AFCIs with other protective devices such as AFCI receptacles or surge protectors to streamline installations and save space. Sixthly, inspectors will need to carefully verify that installations meet the requirements of the exception, paying close attention to the wiring method and the distance between the overcurrent device and the AFCI. Seventhly, homeowners and building owners should be informed about the benefits of AFCI protection and the importance of proper installation and maintenance. Eighthly, electrical safety training programs should be updated to reflect these changes in the NEC and provide guidance on how to properly install and test AFCIs. Ninthly, the cost of AFCI protection may be affected by these changes, as combination type AFCIs and the use of metal raceway or metallic sheath cables can add to the overall cost of the installation. Tenthly, ongoing research and development are needed to improve AFCI technology and address any challenges that may arise with the implementation of these changes. The proposed revision addresses concerns regarding practicality in certain scenarios, such as long branch circuits or multiple circuits in a single raceway, making installations more feasible without compromising safety. Allowing combination type AFCIs offers comprehensive protection by detecting both parallel and series arc faults, enhancing overall safety.